Hello, for data communications and network one class today, Jalsa will talk about how does the internet work. Okay, and this is the AI generated image of the internet. So this is how the AI think of the internet. Okay, but basically internet is the internet work, right? So you have like many networks. Okay, connect together maybe by a router. Okay, so you may have like connect like this. Okay, and this may be a wide array network. Okay, you have like maybe this is wide array network. Maybe this is bus LAN. Okay, maybe this is star LAN. Okay, this is maybe Ethernet, right? Ethernet LAN. Okay, this is maybe star LAN. Okay, this is maybe another WAN. Okay, something like that. Okay, WAN 1, WAN 2. Okay, and this is router. Okay. So to make the internet works, okay, we send the data into packet. So different the packet may have different size for different protocol. Different network, okay, they use different protocol. So this has like this maybe like protocol 1, protocol 2, okay, something like this, protocol 3, protocol 4, okay, something like that. So if you have different protocols, you can have different size, okay, of the packets, okay. Last year I was still teaching the asynchronous transfer mode, but since it's very old now, we skip it, okay, asynchronous transfer mode. But I like to mention it here because this one very small, okay, one cell or one packet, but it's called cell, 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 is only 33 bytes, okay, this is very small for this protocol, okay. Usually it will be like thousands of bytes, okay, for like one packet, but this is only 53 bytes, okay. So you can see that different protocol, they can have like different size of the packet, okay? And the protocol is the main thing that we talked about, okay. And the main protocol is TCP/IP, Transmission Control Protocol, Internet Protocol / Internet Protocol. This is a protocol suite, okay, and we will talk in detail about them, okay. This is the main protocol for the internet. And then we have hardware, which is the router. Router is the device, okay, that do the routing, okay, do the routing of between networks, okay. If you remember, okay, we have talked about in the packet switching network, we have talked about this before. We have like this cost routing algorithm, and also other algorithm, for example the Bellman-Ford algorithm, Dijkstra algorithm, okay. That one inside routing inside, this is inside a network, okay, routing inside the network. So the node make decision, okay, when it receive a packet, it make decision, okay, which way to go. I go this, or I go this, or maybe I go this, okay. So this is it make the decision, right? But for the router, this is making decision between networks. So it get the packet from here, then it make decision which way to go, right? this way or this way, okay, to go to the user that we want, because our user maybe sender is here but destination is here, okay. This is between many networks, okay. So router do the routing, okay, but in different scale, okay, as what we have done before. Dijkstra, Permanent flooding, okay, they were inside a network, but the same idea, the same concept can be done for router also, okay. They set set up like how to go, okay, the routing algorithm, okay, in the level of like between networks, okay. Now let's look at the internet protocols. I'm not talking about the header yet, okay. I'm talking about the concept that the main concept that IP internet protocol is unreliable, okay. This is very important, and also connectionless, okay, and a datagram protocol. If you remember again, in the packet switching, we have in the packet switching network, okay, we have two types of network. We have the virtual circuit and datagram. If you remember, the virtual circuit network, okay, is connection oriented. Suppose you have like this. Suppose you want to send from A to B, okay, and this one you have to set connection first, okay. You set connection, and every packet will follow the same route, okay. This is connection oriented. Okay. This is virtual circuit network, and then we have the datagram network, okay. Datagram network, this is a review, okay. We have talked about this before when we talked about the packet switching network, okay. For datagram network, suppose you want to send from A to B, okay. The first packet, okay, may go this way, but the second packet may go this way, okay. You see what I mean? They can go different route, okay. The packet from A to B can go, the first packet can go one way, the second packet can go a different way for the datagram, okay. So this is connectionless, no connection, no setup connection before transmitting, okay. And it's unreliable, so it does its best to get a transmission through to the destination, but no guarantee, okay. Unreliable means there is no guarantee. It's just a best effort delivery service, okay. So I think everyone experienced this when you try to download some files, okay, and it doesn't work, okay. It's just stop, it's not loading, it's not finished loading, okay. So there's no guarantee that when you send, it will arrive, okay. So this is like sending unregistered mail, okay. The post office does its best to deliver the mail, but no guarantee. If you want to guarantee, you have to register your mail, okay. You have to send like more expensive, okay, to make sure that it arrived, okay. But 90-something%, okay, of the time, even though you are not register your mail, okay, it will arrive, right? So the same as IP, they try their best to send your packets, okay, but no guarantee. So if it doesn't work at this time, then you retransmit again, you send again, you upload again, you refresh your page, okay. Now why does it has some like sometimes it doesn't work, okay, you upload or you download, maybe because of congestion, okay. They have many problems, okay, in the network. For example, congestion inside network, okay. So if there are many like many people, like traffic jam, okay? There are many packets, many users trying to send at the same time, okay? Then it doesn't work, right? Not everyone will arrive, okay? So that's why I say it's no guarantee, okay? But if reliability is required, which is usually the case, when you transmit your data, you want it to arrive at the destination, then IP must be paired with a reliable protocol such as TCP or the transmission control protocol. This one is connection oriented. Okay, this protocol connection oriented, so you have set up your route before you transmit. You have like kind of feedback, okay, to tell you like AIQ, okay, to tell you if you work, you send and it receive correctly or not, okay. So this is a TCP, but the IP you just you don't tell the sender, okay. If it doesn't arrive, okay, you don't know. Okay, so usually you pair the IP, the Internet Protocol, with the TCP so that you know what is going on, right? To make sure that it arrives, or if it doesn't arrive, then you get the feedback, something like that. Okay, now let's look at the communication step of the Internet. Okay, first we have the transport layer. As I say, TCP IP protocol suite, okay, is the one that we are using. Okay, so we have the transport layer, check the data stream, okay, suppose like this, okay, and then break it into datagram. Okay, so you kind of group it and then put header on, so it becomes datagram. Okay, then each datagram is transmitted through the internet, okay. It may be fragmented into smaller units, okay, because if, as I say, you can have like some protocol, okay, that is use smaller packet size, so you have new header, okay, for that. So one datagram is fragment into many units, okay, smaller, depend on the protocol that in that network that you try to transmit. When all of these units arrive at the destination, okay, the IP in the protocol will reassemble them, okay, into datagram, become datagram again. So you take the header of smaller unit out, okay, you get the datagram back. Then the datagram are handed to the transport layer, okay, of the destination, and the transport layer will assemble the datagram into the data stream, okay, become data stream like this. Okay, now this is why the transmission control protocol, or TCP, as I say, is a dominant, TCP is dominant commercial architecture. This is kind of strange, okay, because the standard was actually called OSI model, okay, Open System Interconnection. This is the international standard from the international organization, but no one used it, okay. TCP/IP came before. It came before OSI, okay. OSI was too slow, okay. So when everyone trying to connect with the computers, okay, into networks, okay, and network together, they use TCP/IP. Then the new user want to join, so they use TCP/IP again. Everyone using TCP/IP. Then OSI model come out, the 7-layer OSI model come out. No one use it, okay. So I know say that OSI is a beautiful dream, but TCP/IP is and TCP/IP is living it, okay. If you want to know the like the history, okay, of the OSI, the OSI, the internet that wasn't, okay. So you can read this reference. Okay. So this is the 7-layer OSI model that I talked about in the overview, in the introduction part, okay, of this course. So it has a 7-layer here, and it define like different tags nicely, okay, like physical layer, detailing layer, okay, whatever. But the TCP use only this layer, okay, so mainly transport layer, internet layer, then you have application layer, and then you have the network access. That's it. Okay, now how we encapsulate, okay, protocol data units, okay, for the TCP/IP architecture. To see the simple structure, okay, you have this picture here. You have user data. This user data, okay, go down to the this is application layer, go down to the TCP layer. This is called TCP segment. The TCP segment is the user data added with the TCP header, okay. Then it go down to the whole thing, okay, go down to become data of the IP datagram, okay. So you add header, okay, so become IP datagram, the whole thing here, IP datagram, you have header of the IP. And then you have the network level packet, okay, so you add the header of the network layer, okay. So the upper layer, block, okay, of data, they go down, and then you add header, and then go down again, you add header again, something like that. Now notice that at every layer, when you change the protocol, they call different name, okay. This is block of data, they call with the header, they call TCP segment in this layer, but in the internet layer, it's called datagram. Okay, if it's like LAN, okay, we call it a frame, okay. If it's like network, like wired network, we call it a packet, something like that, okay. And there's also a general name like protocol data unit, okay. This is general name, like we put it like PDU, okay. So different protocol, they use different name, and this may make it a little bit difficult for students, okay, as they call the similar things, okay, with different name when you have different protocol, okay. When you set up different protocol, then they set up a new name, okay. So the segment or datagram or packet or frame or protocol data unit, they actually means a block of block of data with headers, okay. Okay, now if you want to look at in more detail, maybe more beautiful picture, okay. You have this is the TCP segment, okay. You have the TCP header. It's actually similar things, okay. And you have the upper layer, data, and then you go down, and then this is like layer, okay. So this 3, 4, 2, 1. And the IP datagram, so you have this whole thing go down, the green one go down, and then you add the IP header, okay. And the layer 2, you have this is Ethernet frame, which is so we use LAN here. We can use wired network also, but if it's Ethernet, it's called a frame, okay. This one you have the header and you have a footer, or because in the LAN, okay, they have a header and footer. Anyway, the whole thing of the blue, okay, go down here, okay. And then you go to layer 1 is the physical layer. Physical layer is the layer that you actually sending to like signals, okay, waves, okay, into the transmission medium, okay. So you have 1, 0, 0 like this, okay, binary, and then this one you use line coding. We have talked about line coding before, if you remember, NRC, Manchester, something like that, Manchester, okay. This is in the old videos, okay. In the when you do like digital to digital modulation, digital to analog modulation, okay, in that topics, okay. So you change the 100 into like low and high voltage, okay, and you send like the waveform, okay. Then you can also change this into like using like ASK amplitude shift keying, FSK frequency shift keying, phase shift keying to send to the transmission media. Okay, you can review this. Okay, when we talked about the ASK, FSK, PSK, or line coding, or NRCI, NRCL, Manchester. Okay, in that topic. Okay, I will not repeat them here. Okay, now we know about all this, but okay, again, I want to emphasize how does the internet work. Okay, since you know that we add header, okay, at every layer. Okay, so now we look at the network. Okay, suppose we have network like this. You have routers here. Okay, and suppose this network is you are here. Okay, and this is wide area network. Okay, wide area network 1. Okay, so you send, okay, here you have like one protocol 1. So you have your packet must have the header of protocol 1, right? Protocol 1 header here. Header of protocol 1. Then it can send, then it go to the router here, because maybe your destination is here. B is here. When you send to B, maybe it's use bus topology. Okay, so B use Ethernet protocol. Okay, Ethernet LAN. Okay, so B is connected to the bus here. Okay, so when it packet arrive here, okay, suppose this one use broadcasting. Okay, your packet, okay, at this point would be you take this header out. You take this is protocol 1 header. Okay, you take it out. Okay, and then you add Ethernet header and Ethernet footer here, and then you can send inside, inside of the Ethernet LAN. Okay, now suppose you want to send to C, and C is here, and suppose C this one use star maybe wireless. Okay, okay, so this one this is router. Okay, so this one get the packet. Okay, like Ethernet packet. Okay, from this, and it have to send here, so it will change. Okay, it will change into the packet. This is B, right? Like suppose you want to send to C. You send here. You take out this, and you do put the new protocol 3 header. Okay, header over here. Okay, but your data are still the same. Okay, your data are still the same data inside. You just change the header. Okay, so that they can go through different protocol. Okay, do you understand this? You have, if you want to, okay, think about this. Suppose this is like you in the air, you go by plane. Okay, you want to travel to some like countryside. Okay, far away. Okay, so this one Protocol 1 is like you take a airplane, okay? So you fly with the airplane. You are the data, okay? You are inside, you fly with the airplane. Then you go to the maybe Ethernet LAN, maybe this is a boat or a ship. So you get off the get off the plane, and then take a boat, okay? Take a boat or a ship, okay? Then when you go to this, the last one, okay, maybe you take a bus, okay? So you are the data inside from the upper layer. You are all the same, okay? You just use different method in order to travel. You use different protocol in order to travel through different networks, okay? Using bus or plane or train or boat, okay? These are representing different protocols, okay? So this is how the internet works, okay? They keep the inside the same, add the correct header or footer to go through that network, okay? So that they can do routing, or they can arrive to the router that they want, okay? Or to the destination that they want, if this is the end, okay? So just focus that you are the data, and you use different mode of transportation to arrive at the destination. So the packet, they do the same, okay? They add header, and then they off this protocol, then go to the next network. They take out, okay? They take out that header, and then put the new protocol header, so that they can travel inside of that second network and then go to the third network. They take out the header of the second network and put the header of the third network, okay? So I hope this now you know how the internet works, okay? How they can go through different protocols, okay? Thank you very much.